this section, we are going to take a look at special right triangles. Right? Two triangles in particular that we just have randomly decided they are special. The first one is any triangle that has these three angles: 45 degrees, 45 degrees, and 90 degrees.
That's pretty special.
It is. Right? So this is an isosceles right triangle. Right? Any isosceles right triangle will have to have these angle measurements. Right? Because if we're saying one of the angles is 90, and we have two sides and angles the same, the other two angles would have to be 45. Right? Now, if we have those angle measures, the sides will always have a certain relationship. Right? This is that relationship. We've already talked about that in an isosceles triangle, two angles are the same and two sides are the same. Right? So these two legs of this 45, 45, 90 right triangle will always be the same. And the hypotenuse will always be the length of one of those legs times the square root of 2. Right? So let's prove that first here. Right? So let's assume that both the legs are x, and then let's solve for the hypotenuse. Right? So let's just call this c for now. So we'll have x squared plus x squared equals c squared. So these are like terms. I can combine them. Right? This would just be 2x squared. And now I can just take the square root of both sides of the equation. So when I take the square root of something like this that has multiple terms in it, I take the square root of each piece separately. So this would just become the square root of 2 times the square root of x squared. And the square root of x squared, something we've talked about, a square and a square root cancel each other out. So this just becomes x. Right? So we would have the square root of 2 times x, or since it's multiplication, we can rearrange the order and just write it as x times the square root of 2. So this relationship will hold for every 45, 45, 90 triangle. Less. So in example 2, they tell us that the hypotenuse is 6. We want to find the length of each leg. So you get a triangle that looks like this: 45, 45, 90. And I know the hypotenuse has a length of 6. How would we find each leg just knowing this relationship? So we could do that. Yeah, we could go through this process. We could say, so we know that the hypotenuse is 6. Yeah, so if we're thinking in terms of something like this, we could set it up as the Pythagorean theorem. It's not going to be 3. So think if we made each of these sides 3, the hypotenuse would be 3 times the square root of 2, which is not 6. It's not going to be the square root of 3. It's not going to be 9. So that is one way that we could do it. So let's do that here, and then I'll show you the shortcut. So we could set it up like this, right? Saying that each of these sides we know are the same. So x squared plus x squared equals 6 squared. Right? So then 2x squared equals, I guess I can go ahead and square that, make it 36. So then to solve for x, I would divide both sides by 2. Get x squared equals 18. That take the square root of both sides. And x equals the square root of 18, which we want to simplify. So what's the largest perfect square that would divide evenly into 18? 9. So we could split this up into the square root of 9 times the square root of 2, which would be 3 times the square root of 2. Right? So we end up getting that each side here is the square root, or 3 times the square root of 2. Yes, I'll show you why here. So,
I figured that out.
So first, if we think about over here, this relationship, if I make this side 3 times the square root of 2, well then we know the hypotenuse is just one of the legs times the square root of 2. So if I take 3 times the square root of 2 times the square root of 2, well, this would become 3 times the square root of 4, right? If I've got radicals, I can multiply what's on the other side. And we know the square root of 4 is just 2. So we would get that the hypotenuse is 6 using that relationship. Okay? So I was just showing that this works with the relationship that we just talked about. So if we take this side, and we know that the relationship between one leg and the hypotenuse is we just take the leg times the square root of 2. So if I take 3 times the square root of 2 times the square root of 2, I get 6, which is what we just showed. Just showing that this relationship holds for that idea. Alright, so the shortcut. If I know the hypotenuse, I can set the hypotenuse equal to x times the square root of 2. Okay, we're solving for x here. So if I just say 6 equals x times the square root of 2, I want to solve this equation for x. Well, all I would need to do is divide both sides by the square root of 2. And I end up with x equals 6 over the square root of 2. Did you guys talk about rationalizing denominators last year in algebra? Okay. So that's what we would want to do in this situation, right? We cannot have a radical in the denominator of a fraction. To get rid of that, in something like this, all we're going to do is multiply the numerator and denominator of the fraction by whatever that square root is. So I'm going to multiply top and bottom by the square root of 2. Why am I allowed to multiply something by this? Because that's 1. Right? And multiplying anything by 1 doesn't change its value. And so that's why this is okay. So what ends up happening then? Right, I will get 6 times the square root of 2 in the numerator. Now what's the square root of 2 times the square root of 2? The square root of 4, which is just 2. Right? So whenever we're multiplying a square root by itself, that's essentially squaring the square root. So we just get 2. Just an inverse operation. And then finally, I can reduce this fraction. So 6 over 2 is just 3. So this becomes 3 times the square root of 2, which is what we found doing it a long way using the Pythagorean theorem. It's not a bad idea at all. Okay, I'm just showing you a shortcut.
Do we have to show this that if we do that, we have to show this that the fraction should be like 6 divided by 2 is 3.
We're not going to be that easy.
Well, sometimes they will. Okay. Yeah. I mean, you can just. I mean, the kind of the whole point of this chapter is, or I'm sorry, this section is to memorize this relationship in a 45, 45, 90 triangle, and then the other one we're going to look at on the back is a 30, 60, 90 triangle. Okay. So, for each of these problems, when we're finding a missing side in these triangles, you can always use Pythagorean theorem. Right? You can always do that. We can always use this idea if we forget this relationship. Okay? But this is going to make these types of problems a lot easier. And we're not going to do a ton with these in this class, but in pre-calc, you will do a lot with these special right triangles when you get into trigonometry.
Don't even talk. You don't want-
I'm assuming that most, if not all of you, are going to take pre-calc. Okay, so this is something that you will definitely see again in pre-calc.
Is there calc?
There is calc, yes.
I just didn't know.
Raise your hand if you really want to. That is not that many.
Why would we take algebra? We want to take algebra.
You're a college.
All right, so let's take a look at a couple examples of the 45, 45, 90s down here real quick.
How far is this one? About-
Here it is.
So yeah, let's do number one together.
Okay. So you know how your x square root of 2 equals c? Then you just do a, times the square root of 2 equals the x and then find x that way.
That is the answer.
Oh my god.
So we know that in this triangle, to get the hypotenuse, if we have one of the legs, it's just one of the legs times the square root of 2. Okay. So let's take a minute or two here and see if we can get the rest of them.
Wow. So I'm trying to do
Yes. Oh, I guess another thing I should mention, on the official formula sheet for the air test, you are given the special right triangles. Right? You're given those relationships. So you are given a triangle that looks like this. Right? And then you're given the other one that we'll talk about here in a second. Those are on the formula sheet for the air test. So the point of this section is to give you that shortcut so that it is less work for these triangles. Well, the square root of 2 is a decimal. It's like 1.41 something. It's So if you actually put this in a calculator, you'll get a decimal.
Oh, I got it.
So yeah, this number is always. All right, did we get these answers here? So the point of this section is to give you the shortcut, right? I mean, we showed our work on the two examples up top just to kind of prove that this works. But once we recognize this relationship, we shouldn't have to do any work, right? We just know that the hypotenuse is the square root of 2 times one of the legs. Well, and then if I'm given the hypotenuse, the leg is just the hypotenuse divided by the square root of 2. Right? If the hypotenuse is a whole number, and we go through that process of dividing that number by the square root of 2, the leg will always end up being half of whatever the hypotenuse is times the square root of 2. Okay, so if I went through the process of saying 18 divided by the square root of 2 and rationalize this, multiply top and bottom by the square root of 2, so I get 18 times the square root of 2 over 2, and 18 divided by 2 is 9, right? That's how it will work out every single time for a 45, 45, 90 triangle. Right? Questions on the front? What's that? No, these are easy. We're going to do the back too. Okay, so the other one that we're going to look at is a 30, 60, 90 right triangle.
It's just gonna be like third.
We'll see. So, in this example here, they just give us that the shorter leg, which would be the one opposite the 30-degree angle, is exactly half of the hypotenuse. Right? The hypotenuse is exactly twice the shorter leg. So let's figure out what the other leg is. So let's set this up as x squared plus a squared equals 2x squared. And remember, whenever we're squaring something that has multiple terms, we need to square everything there. Right? So here we would have x squared plus a squared equals, if I square both of these things, this would be 4x squared. Right? 2 squared times x squared. Then to solve for a squared, we're going to subtract this x squared over. Get a squared equals 3x squared. So now I can take the square roots of both sides to solve for a. And just like we did on the front, whenever we're taking the square root of something that has multiple terms being multiplied, I take the square root of each one individually. So the square root of 3 times the square root of x squared. And the square root of x squared is just x. And the square root of 3 stays. Okay? So this is the relationship that we're going to look at for 30, 60, 90. If we know that the shorter leg, which is the one opposite 30 degrees, is x, the other leg is that shorter leg times the square root of 3, and the hypotenuse is just exactly double the shorter leg.
So it's just like one extra step.
Yeah, because the legs aren't the same for a 30, 60, 90. Yeah.
I think you so x, whatever, at the top, and the other leg is what?
So Which leg? The X leg?
Yeah.
So the one that's opposite the 30-degree angle is the shorter one. So we'll call that X. The other leg then, the one opposite the 60-degree angle, is just whatever this is times the square root of 3. And then the hypotenuse is just whatever this is times 2. So let's do an example here. In the second example, they tell us the hypotenuse is 5, and we want to find the other 2 legs. So draw our triangle, and we know the hypotenuse is 5. So I know that the shorter leg is exactly half the length of the hypotenuse. So if the hypotenuse is 5, the shorter leg would be 2.5. Then the longer leg is just the shorter leg times the square root of 3. So 2.5 times the square root of 3. Say it again.
Same.
Yeah, it's just this leg times the square root of 3. Just like on the other side, hypotenuse was just one of the legs times the square root of 2. Okay. Questions so far?
Alright. Let's. I think I want to do one of these together.
Nah. Let's just take a couple of minutes and have you guys try them. The only one that's a little bit tricky, I think, is number 5. Okay, so give number 5 a try, but we'll go over it here in a couple of minutes. I think the rest of them, there really isn't much work to show. We're just using the relationship that the hypotenuse is double the shorter leg, and the longer leg is the square root of 3 times the shorter leg. Not times.
Divide by.
Right, it has to be shorter. So if we think about a relationship, we're saying that this is x times the square root of 3. So we would divide by the square root of 3 to get this side. Right, whatever we get for here, we multiply by 2 to get that one. Well, I want an exact number, so you shouldn't even put it in the calculator. I don't want a decimal, I want the exact number. So you would have a square root of something in your answer. Just like you do here, like 5.5 times the square root of 3 or 10 times the square root of 3.
You want us to do the equation.
Yeah. Yeah.
So x divided by the 3.
So we would take this side and divide by the square root of 3, to get the shorter leg.
How do you get an exact number?
4 times the square root.
How do you get an exact number not that?
So, kind of like what we did on the front, we're just setting 12 equal to x times the square root of 3 and solving that. So we would divide both sides by the square root of 3.
Oh, okay.
And then simplify this, like we did on the front, rationalize the denominator. So this would become multiply top and bottom by the square root of 3. Get 12 times the square root of 3 over 3. So then 12 divided by 3 is just 4. this side ends up being 4 times the square root of 3. So x is going to be 4 times the square root of 3 over 5.
So that in your head, you just take a quarter of 12 and then times the third.
Okay. This is too much number here. This is too much. But to like process and remember all that, you just go to 12 and range.
If you're given the longer leg, or 30, 60, 90,
What if
yes.
we're given the short leg? We just multiply by 3 and take away the thing.
Well, if we're given the shorter leg, then it's easy, right? Then we just multiply by 2 to get the hypotenuse and multiply by the square root of 3 to get this one. Like
Why would we multiply this?
on this one, right? We were given the shorter leg. So to get the longer leg, just multiply by the square root of 3. To get the hypotenuse, just multiply by 2.
We should multiply the square root of 3. How would we multiply it? Why can't you just multiply it by 3? Because it gives us the same number. Like, why would you say square root of 3 and not just 3?
4 times the square root of 3 is not the same thing as 4 times 3. The square root of 3 is like 1.7 something.
But that one, 4 times 3 is 12.
Yes, and 4 times the square root of 3 is 7 point something.
You're saying multiplying, I don't know how much is combined.
Yep.
Real quick, okay, this last one here has a word that we haven't really talked about. Altitude is just the same thing as height. So this one we've got an equilateral triangle, so we know all sides are the same. And then the height, we're saying, is 36. So we're saying this side is 36. Now if we know this is an equilateral triangle, that means the angles are 60. And if I cut it in half with a height, we would create a 30, 60, 90 right triangle. So if I know this side, then we can use the same ideas as up here to find the other two sides.